unable to attend. And I want to begin, I had up on the screen and I'll put it back up, kind of our agenda for the evening. Whoops, I hit the wrong button. I'm going to open the floor for questions. If you have questions about the lesson from last week or from your quiz, then we're going to proceed with an introduction to Minitab. You do actually have access to Minitab now. And then we're going to get into the discussion on data displays and descriptive statistics, which is the second lesson in Module 1. It's actually entitled Descriptive Statistics, Missing Data, and Outliers. And as we go through some of this information tonight, we're going to be thinking ahead and thinking about mini project number 1, which is due on January 29th, which is about a week and a half out. It's due on Sunday, January the 29th. So let me open the floor to see if any of you have questions from last week's lesson, from the homework quiz, or any general questions before we get into tonight's lesson. You may unmute and speak, or you may type them in the chat. Okay, I'm not hearing any questions and I don't see anything in the chat. So we are going to move forward. And it may seem a little odd, but I do want to begin with the introduction to Minitab for several reasons. One, because we are ultimately going to use Minitab to help us create those visual displays, the graphs. We can use it to create some tables and that kind of thing. So I want you to kind of have the introduction, and then we can get into specifically how to use it. So if you noticed on that outline, I'm going to show you how to get logged in, how to upload a .cvs or a Excel file, how to upload a .mtw or mpw, which is a specific type of Minitab file, and then talk a little bit about how it is set up and how it works before we actually get into actually using it to do our statistical analyses that we're going to talk about a little bit later tonight. Now, in the course, if you log in to D2L into the course, on the landing page, on the right-hand side, where you see the content, if I scroll down, well, actually it's under the start here. If you go to start here, there is a page entitled Minitab Online. Okay, so on the landing page, under the content, start here folder, Minitab Online. And this gives you the instructions on how to access Minitab. Now, you have to use your Georgia Highlands College email address. As long as you have internet access, you should have access to Minitab, regardless of whether you have a Mac or whether you have a Windows-based computer. So I'm going up to the top and I'm going to open a tab and I'm going to type app dot Minitab, MINITAB.com. You may want to bookmark that page because you will be going there a lot. It is app.minitab.com. You have to put the app in front of it because that gets you to the web version of Minitab. So I hit enter and it takes me to this page. It asks me to sign in. You must use your Georgia Highlands email address. So I would type my Georgia Highlands email address. Now, I will keep myself signed in because this is my personal device. No one else uses it. And so I don't have to do this login every single time. If you are not on a personal device, do not do that. Then we click next. And it's thinking about it. And it took me directly to the page, the Minitab page. You may have to actually go through the Duo security for Georgia Highlands. There was also, let me sign back out again. My account is already set up. If you don't have an account, you may have to set one up. Guys, if you set one up and you put in a password, you got to remember the password because you're going to need it every time you access this, and we will be accessing it on a regular weekly basis because we're going to be using it a lot. Okay, again, usually it'll take you through the Duo security, but I was already logged in. Okay, so you get logged in. When you are logged in, you should come to a screen that looks like the display on my screen now. You really have three different windows, if you will, or three different regions. On the right-hand side, the lower half looks very similar to an Excel spreadsheet. Okay, it's a little bit different. Instead of labeling the columns with the alphabet A, B, C, D as Excel does, Minitab uses the letter C, which stands for column. So you have column 1, column 2, column 3, column 4. The rows are also numbered. But one of the nice things about Minitab is you have this extra grayed out area under the column number where I can put a label. So if I were going to put ages in here in years, I can type that header or that label for that column in that grayed out area. And that's the purpose of it. Now, if you have a OneDrive and want to use it or a Google Drive, you can. I usually don't save anything with Minitab. If I need to enter another column, maybe I'm going to do gender or ethnicity. Okay. So I can then begin, entering the values. Maybe I would have 19, 23, 27, 32, maybe 21. I'm just making numbers up. Maybe I have male, female, female, male, female. Again, I'm just making it up as I go. Okay, maybe for ethnicity, we have maybe Caucasian. Oops, I didn't spell it right. Let me just put white because I can't remember. African, American. Maybe we have white. Maybe we have Latino. Oops, spelled it wrong again. Okay, so if you have to enter your own data, It is pretty much just like entering stuff into an Excel spreadsheet. You have this extra gray area for the label. And guys, you should never, ever enter data without indicating what it is. And notice I also indicated that the age was stated in years. Gender doesn't really have a unit. Ethnicity doesn't really have a unit. If we were going to do height, I might indicate that it's in inches. Or if I were going to do weight, I would indicate that it's in pounds. Okay. If it's a measurement, it's best to include the units because that helps later on with the interpretation. But it's just like entering numbers into a spreadsheet. The data is entered. Notice when I entered it in a column. I did not put it in rows. It is in a column. A data set, one data set per column, one variable per column. I only have ages in the first column. I only have gender in the second column. I only have ethnicity in the third column, and so forth. You have one variable per column. Column runs vertically. Okay, I'm being very deliberate because I've had issues in the past with students trying to put the information in rows, and guys, it does not work that way. Also notice Minitab is very helpful in identifying whether you have quantitative data, which is numbers, or whether you have qualitative data. Minitab recognizes that. For example, in column 1, notice that my column name is just C1. So it is likely that C1 contains numeric values. But if you notice, C2 and really C3 now say C2-T or C3-T. T stands for text. T-E-X-T. Text, words, phrases. So Minitab recognizes that those two columns are qualitative data. They indicate that with the T standing for the word text, T-E-X-T. And it will not let you use those columns if it's not appropriate. If we were entering maybe a birth date, like 10/30, I'm going to put 1968 because that's the date I know. Okay, notice how now that column is labeled C6-D. D stands for date. Again, Minitab is programmed and is smart enough to recognize that that is a date. And again, it's not going to let you perform calculations with that information because it would be inappropriate. Okay, so it's pretty easy, and again, it's got a little bit of intelligence with it because again, it can help you identify whether your data is qualitative or quantitative. Any questions so far? The top half of the right hand side where you kind of see the Minitab logo is kind of like your workspace. This is where the results will appear. So like if I wanted, and you don't have to pay attention to this, but if I wanted to create a graph of, say, the gender, whoops, then once I give it the commands and walk through the commands, that graph appears in the top. On the left-hand side is called the navigator. So the first thing that I created was a chart of the gender. If I now go out and I create a chart of the ethnicity, okay, now it says chart of ethnicity. So it's like it keeps track of all the different things that I've done, and I can toggle back and forth between those things. Okay, so the navigator, I honestly don't really use the navigator a whole lot. It's there, but if I need to go back and forth between different analyses or different graphs, I can do that. Now we'll get more into detail about how to actually create those graphs in detail a little bit later. But again, you have basically your spreadsheet on the lower right. The upper right is your workspace, and the left-hand column is kind of your navigator or your file. Okay, the other thing that you're going to be asked to do throughout this course is to upload a data set to prevent you from having to enter the data by hand. Okay, in many cases, I give you the data set. For example, if I go to Module 1 and tonight's lesson on descriptive statistics, missing data, and outliers, and it's thinking about it really hard. When it comes up at the very bottom of that landing page where you see the link to the quiz, there's also a data set that you need for that quiz, and sometimes I have to go back and forth here, so I don't know why it's taking so long, but you have to go to that. You have to download that data set, but then you have to upload it to Minitab so that you don't have to manually enter the data. Okay, so I'm trying to get this to open. Aha, there it went. Okay, so again, if I scroll down to the bottom, there's the hospital patient data, and I give it to you in a Minitab format. I also give it to you in an Excel format. That's one that's used in some of the examples on the videos. I'm not going to use them tonight, but for quiz 2, you have the data in Minitab format. Minitab data comes in 2 different formats. Okay, Minitab data comes in 2 different formats. One of those is a .mtw. That means you have just the worksheet. The other option is it comes in a .mpw. MPW is a project. Now, you have to pay attention to that suffix or to that ending, because knowing whether you have a worksheet or a project is important when you go to upload it. So we're going to talk about this Minitab file first. Okay, so for quiz 2, I've given you the data that you need in Minitab format. It clearly says Minitab format. It also says MPX. You will have to download this data set. However, once you have it downloaded, do not try to open it on your computer. It will not open. It will give you an error. It will only open inside of Minitab. So if I click on this data set so that it downloads, now I want to put it somewhere where I can remember where it is. I keep a folder on my desktop called dataset. So I have the quiz 2 data. I'm going to save it again. Okay. Notice it says Windows can't open this type of file. It's okay. But I have it downloaded. I know where I put it. It's in my dataset folder. I'm going to Minitab. And I want to upload that data set. So to upload that data set, I'm going to go to File, Open, and because it had the suffix MPW, I know it's a project, so I want to open the project from a local file. I choose the file, quiz 2 data, and it loads. And again, you can save it if you want to, or I do without save. And so I have my data set. Okay, I have age, I have sex, the chest pain type, the resting blood pressure, cholesterol, and so forth. So I have the data. It automatically populates for me. Okay, I'm going to walk through it one more time. You have to download the data by clicking on it. Put it where you can remember where it is. I am going to save it. It gives me the error. I know that the Windows will not open it. It's okay. I'm going to Minitab. File, Open. It's a project because it has MP for project, W, from a local file. Select the file you want, and it loads. Again, I do it without autosave. Now, I want to use this file later, so I'm going to tell it I want a new worksheet. The other option that you have is sometimes the data is in an Excel format. For example, this hospital comparison data is in Excel format. I can, again, select it. I can save it, but notice it's a .xlsx, okay, because it's in the Excel format. Now the Excel is going to open, and I have to open it. It's thinking about it. So I have that file opened. Basically, you're going to copy and paste to get the Excel sheet into Minitab. It's purely copy paste. Okay, so I put my mouse in the corner where the rows and the columns meet. There's this little box with a half triangle in it. I'm going to click in the box. It highlights every column, every row. And then I tell it to copy. You can usually see, it's hard to see, but you see little dancing ants all the way around the spreadsheet. It is copied. So then I go to Minitab. This is very important. Put the mouse in the header grayed out area under C1. And then I tell it to paste. And it pastes that data. Okay. Questions on how to get the data from Minitab from the computer, from D2L to Minitab. There are, under Mini Project 1, I believe, nope, I didn't put them there. Okay, under, let's see, where did I put them? For the lesson for today, descriptive statistics, missing data, and outliers. There are 2 videos. The first one shows how to upload the Excel or .csv file. That's the copy and paste. Then I also have one that walks you through how to do the .mpx. Okay, so those videos are there, and they're, I go through it several times. The other thing that I want to mention, and I showed you how to do this because for the mini projects, and I'm going to go to Mini Project 1, for the mini projects, you have been assigned a particular data set. It says, throughout Business 3000, you will be asked to complete a series of mini projects that allow you to apply the statistical procedures and processes you are learning. You will need to use Minitab or other statistical software to complete all the mini projects. I used to let students choose from a variety of data sets, but with 40 students in the class, that was challenging. So I have 2 data sets. If you're doing the BBA in logistics and supply chain management, I have a supply chain data set. If you're doing the BBA in healthcare management, I have a heart disease data set. Now, it clearly says that the supply chain data set is in Excel format, which means you have to copy and paste to get it into Minitab. The heart disease is a .mtw, so it's a worksheet. So you would upload the worksheet. Okay, so depending on which BBA program you're in, you may either use copy and paste or you may have to do the upload. Again, those videos are here should you need them. The other thing that I want to stress to you as you begin to think about doing the projects, and I'm going to pull this one up for heart disease. For each one of these, I give you information and helpful hints for heart disease data set. And then I say, please review this document before starting the mini projects. This information tells you what, like the variables, what each column represents. It gives you an overview of the data set, which is important to know. You didn't create the data set, so you need to know what information is there. Okay, so researchers were publishing detailed information about factors that affect heart disease. And so it outlines for you what each column represents. For example, under column 3 with chest pain type, they used a coding system. So number 1 stands for typical angina, 2 is atypical, 3 is non-anginal, and 4 is asymptomatic. So sometimes coding is used on some of these. Same thing with the resting electrocardiographic results. Okay. So it walks through what all of the columns, there are 14 columns of data, and it tells you what each one represents. I then give you some ideas, especially as you get further on down into some of the more involved analyses. I provide suggestions. on what you could do. Okay, so that you're not just totally left out in left field about what to do. Okay, so it gives you some ideas or thoughts about what you could do for that analysis. It also has where the data set came from and who worked on it and that kind of stuff. Okay, so it gives you the frame of reference. You have a similar one for the supply chain. Again, please look that over, use the information before you bombard Ms. Ralston with questions, because I've tried to head off some of the questions that I would get. All right, questions so far? All right, we're going to dive back in then to the different types of data visualization. Last week at the end of the discussion, we talked about the importance of data visualization. And so we didn't have time to talk about the different types. The types of data visualization depends upon what type data you have. Okay, the types of data visualization depends upon what type data you have. Now, regardless of whether you have qualitative data or quantitative data, your display, your visual display needs to be self-explanatory. If I had no clue what your graph was about or what your data set was about, I need to be able to look at your visual display and know exactly what it's telling me. So every data visualization, whether it's a table or some kind of graph, should have three things. It should have a title. The title should be as detailed as possible. Again, when you're thinking about giving it a title, think who, where, what, when. And you want to include all that. Now, maybe some of it is, subheadings. Maybe you use footnotes or stuff like that. But the title should be as descriptive and as detailed as possible. Okay, for example, let me go over. I have some examples that I pulled off the internet. In some cases, they're good examples, and in some cases, they're not. This particular one says sales over a 5-week period, day by day. Okay, so they looked at the sales that happened on a Monday for 5 different Mondays. That's really what they're saying. It's a 5-week period, and they looked by each day of the week. They don't tell us what kind of sales. Okay, so that's kind of missing. They also don't label the vertical axis here. I can assume that this was in, I don't know if they're talking about money or if they're talking about items. Okay, so there's missing information here that would make it difficult for me to interpret. The second one is a little bit better because it says sales of books in 1,000 numbers from 6 branches of a publishing company in 2000 and 2001. Now, yes, that's a long title, but it's very descriptive. I know that they're looking at book sales for different branches for a publishing company, and we have data from 2000 and 2001. It also tells me that those values are in thousands. So when you see 10, that actually means 10,000, 20,000, 30,000, 40,000. And then they have them sorted by the branch, which is probably the location of that particular publishing company. So it's important that your title is descriptive as possible, even if it's lengthy. Secondly, it's important to have labels on the axes. What does the horizontal number line represent? What does the vertical number line represent? It's important to include the units. Like, are you talking about dollars? Are you talking about the numbers? Is the measurement in inches? Is it in pounds? What is the measurement? And then lastly, if you need one, you need a key or a legend. Let me go back over to those examples. I pointed out on the first one, again, the title wasn't great because they didn't tell us what they were selling. It did say day by day in the title, and I can kind of figure out that we're talking about Monday, Tuesday, Wednesday, Thursday, Friday, the 5 business days of the week. But again, I don't know on this vertical scale because there's no indication whether that's the volume, whether it's in dollars or what. So that's a problem. Okay, the details are important. Your graph should be self-explanatory. With the second one here, again, it does tell me that the horizontal is the branches and that the vertical is sales, and it's in thousands of numbers. So they're looking at the number sold. There's also the key or the legend down here because the blue represents the year 2000 and the red represents the year 2001. Okay, so every graph, every display should have a title that's detailed with as much information as possible. You should have a label on the horizontal and the vertical axis. And if you need it, you should have a key to indicate maybe what the colors represent or what the pattern represents or whatever. And guys, I will look for those 3 things on the graphs that I ask you to create in Minitab. And we're going to look a little bit later at exactly how to do that. So let's focus for a minute on qualitative data. Qualitative data is your words and phrases primarily. Remember, we said it could be numbers, but it's usually numbers that we wouldn't calculate with. Like your ID numbers, social security numbers, PIN numbers, that kind of thing. So for qualitative data, there's a variety of graphs, and we're going to touch on a couple of them, but the one that you're going to be responsible for is a bar graph. Okay, you have to be able to create in Minitab a bar graph. Okay, it's a very commonly used graph. You'll see them a lot. I see them a lot, like when they're doing weather and they're talking about what the high and the low is going to be. I've seen them used for the chances of rain, whether it goes up or not. So bar graphs can run vertically, as this one does here, or they can run horizontally. More times than not, oftentimes you'll see them vertically. I don't know if one's better than the other, but the height of the bar represents the frequency. How many times does that particular category or group occur? So for example, if I were looking at this graph here on the left, notice it's the county of residence for GHC students in spring 2016. That's my title. So I know what, I know who, I know where, and I know when. The horizontal represents the county of residence, and the vertical is the number of students. So I can see that 21 students live in Bartow County. Only 2 students were from Gordon County. Okay, those values are the frequency. Notice that there are gaps between the bars. because these are stand-alone categories. Okay, somebody doesn't live in Bartow Gordon or Cobb Paulding. They live in one county or the other. They are standalone categories, and that's indicated by the gaps between the bars. Now, most statistical software, Minitab, even Microsoft Excel, you can Google and find free websites that will create a nice bar graph for you. You know, years ago, probably when I was coming through school, we had to do it by hand. We would have to get our little ruler out, you know, and draw, and maybe get our crayons or colored pencils if we wanted it in color. But we have the benefit of the technology. And this is a very quick way. Remember, bar graphs or any kind of graph is a quick way to communicate the information and tell your story. There are other types of bar graphs that occasionally you'll see. You can have the side by side where perhaps you're comparing different groups. The example I showed earlier, they were comparing the year 2000 to 2001. This one, again, if you look at the key here, the black is the total, the blue is males only, and the red or the pink looking color is females. And this is the percent literacy by continent and gender. So again, they don't label it across the bottom here, so that's maybe a problem, but it does indicate in the title that these are continents, and the values on the vertical are percentages. So, you know, for example, in Europe, men and women appear to be fairly equal in terms of literacy at about 90%. For example, in Africa, the total is only about maybe 70 to 75, but more men are able to read than women in Africa. Okay, so it allows us to make comparisons between groups. It's just called a side by side. And for that, you know, for Europe, notice there's not any gaps between those bars, but then there is a gap when you go to the next group, which is North America and so forth. Another form of a bar graph that personally I don't particularly care for, because to me it seems like it's harder to read, is a stacked bar graph where you stack the bars on top of one another and they're based on colors. This one says we're comparing sales strategies, and so you have 8 different 8 different strategies for product A, B, C, D, E, F, and G. Now it doesn't tell me on the vertical what it represents. I have to assume it represents sales. So, you know, if I'm looking at this, it looks like for strategy 6 works best for product B. Looks like strategy 1 works best for product G. But again, it's a little bit harder to read, in my opinion, in the stacked format. So there's different forms of a bar graph, and you have to kind of look and think about what you're trying to do. You know, do you need to be able to compare different groups, or look at the part to the whole? That's probably a good option for the stacked. Another type of bar graph that you'll occasionally see is called a Pareto chart. A Pareto chart is a bar chart, but it puts the bars in height order. This one has it in descending order. You can also see it in ascending order. So this shows, you know, the lack of training, inadequate pay, or unsatisfactory customer service. You know, why are you getting that kind of service? The blue, the bar itself, represents that individual case, but then this line shows us, you know, if you add all of those together, how that it ultimately gets to 100%. So the line shows the cumulative, but again, the bars show each category, but they have them in descending order. So when you have it in kind of an order other than maybe alphabetical, okay, or numerical, then you have, it's a bar graph still, but it's called a Pareto chart. Fancy name. Another one that we use with qualitative data is a pie chart or a pie graph, or you may have heard it called a circle graph. Again, notice we have the title, County of Residence for GHC Students in Spring 2020. Each section is labeled, and it's great if we put the percentage, because again, to me, it would be difficult to look at that piece of the pie and recognize that that's 42%. So a pie chart, each piece of the pie represents the relative frequency, how often it occurs in relationship to the whole. So a pie chart lets us compare an individual category to the entire data set. And again, the bigger the piece, the bigger the percentage. You are not going to be asked to create a pie chart, okay? But it's a good way. You'll see this a lot with budgets to show how the monies are being divided up. Okay, so those are the two primary ones. They're not the only ones, guys. You can also have line graphs and that kind of thing. But those are the two primary ones you see most often when you're dealing with qualitative data, which is words or phrases. Okay, I'm going to pause there, and I want to go out to Minitab and walk you through how to create a bar graph. Again, that's one of the first things you're going to be asked to do on Mini Project 1 is to choose one qualitative variable from your data set and then create a bar graph. I'm going to use this Quiz 2 data set. Now, it doesn't matter whether I've uploaded it as a .mpx or as an Excel worksheet. Okay, it doesn't matter. My data is available. Again, remember, I can look and kind of get an idea which of my columns are qualitative data. C2, which is sex or gender, is obviously text. Fasting blood sugar is text, true, false. Let's see. Exercise angina, do they have exercise angina? Those are going to be yes, no. Their thallium, normal or reversible, and then do they have heart disease? Now, there's actually some others here, because if you go back and think, remember we talked about chest pain type? This is a type, and it's a coding system. And so the fact that it's a coding system, 1, 2, 3, 4, where 1 meant typical angina, 2 was atypical, and I don't remember what 3 and 4 were, but it's on that document. So you actually could do C3, okay? So sometimes it may appear to be numbers, but those numbers are codes that represent words. But I'm gonna stick with the easy one, okay? And we'll look at sex or gender. Okay, so the data is already entered. I've uploaded my data set. I'm going to walk you through how to do a bar graph. Minitab is very logical or very common sense. If you notice across the top, we have drop-down menus. We have File, Edit, Data, Calc, Stat, Graph, View, Help, and so forth. Okay, a bar chart or a bar graph is a graph. So I will go to the top to the graph menu. So I click on the word graph, and it gives me a drop-down menu of all the different graphs that Minitab will create. And so I scroll down until I find bar chart. Pretty common sense. Now, again, Minitab will do it in a different ways. Do you have basically the list of data? That's counts of unique values. Do you have it as a formula, perhaps, or do you have it in a table format? Do you already have it organized into a table? In most cases, you are dealing with the raw data. All I have is a list of the information. I don't have it organized in any sort of way. So I'm using counts of unique values. I'm going to click. I'm only going to look at one variable. That's all you're asked to do. One variable, double click. I then have to choose the categorical qualitative variable. Okay, again, I'm going to do the gender or sex. Notice what I did, okay? The list of all the variables are on the left. I want to do sex or gender, and I'm just going to double click on it. And it automatically pops into my box. On the options tab, it'll default. I can have it do increasing Y or decreasing Y, which makes it become a Pareto chart. I like to put the data labels, and I'll show you what those are in just a minute. But I'm going to click in the box next to data labels. And I'm going to click OK. And then I'm going to click OK again. And in the top half of my screen, my graph appears. Now, it's a little hard to see the entire thing. I'll copy it in just a minute. But I want to show you something. Notice how this title says, Chart of Sex. Okay, that is the default Minitab title. It is not descriptive at all. Okay, I want to change it. I can tell when you do your assignment if you leave it chart of whatever, that you didn't change it. Here's how you change it. Notice how I have the chart or the graph selected. It's kind of got this blue outline around it. In the corner, in the upper right corner, there's a little triangle. I'm going to click on that triangle, and it gives me graph options. So my graph options, and I can change the title. And I might put sex of heart disease patients. Okay, I could go back and get some additional information if I needed to. My x-axis, it does on the horizontal, it indicates that these categories are the sex. That's okay. My vertical is the count, or if you want to change it, you don't have to. That's our frequency. Count or frequency is fine. I'm going to put frequency because that's what you're probably used to. Okay, once I'm finished with that, I can hit enter and close this window. And now I have a more descriptive title. The data labels, that little box that I checked, I can see without having to kind of guesstimate that 97 of the participants were female and 206 of them were male. It puts it at the top of each bar. Also notice, if you're in Minitab and I move my mouse on top of that bar, notice it says bar group is sex, which is the male, and the value is 206. If I do it for the other one, it tells me that that is the bar for female, and it has a value of 97. I need to be able to put my graph into my report. It is a copy and paste. Again, if I select it, using the arrow in the upper right-hand corner, drop down arrow, I'm going to copy the graph. I can then go to my Word document. I can go to my I can go to a PowerPoint. I can go wherever I need to go, PowerPoint, wherever, and paste. Now, once I'm in Word, I've pasted it. I don't have, I can't put my little mouse over the bars and get any information, okay? But as long as I'm in Minitab, I can do that. It's not difficult. Do you have questions? The other piece that you have to do as part of mini project 1 is you then have to kind of write a summary of what that graph tells you. I mean, the graph is the graph is pretty, it's nice, but what does it tell me? Especially if you're going to be writing a report, maybe to hand in to your employer, you're maybe preparing a presentation. You need to be able to explain what's going on that graph. The instructions for the project says create a bar graph using Minitab for the variable that you select. I remind you to put the title and the labels. And then part 2 is you summarize what you learned. What does the graph tell you? And it says use complete detailed sentences. Now I'm going to tell you, last semester I was extremely disappointed and extremely frustrated that students who are in a 3000 level course could not write a complete sentence. The instructions clearly ask you to use complete detailed sentences. And then I kind of give you some ideas about what you should include. Now, I don't want you to go down and answer each one of these questions, but these are some of the things that you should think about when you are summarizing that graph. So if I were looking at this graph, and there's not a whole lot on this one, we would say, this bar graph shows the number of females and number of males who have heart disease. We could say, you're looking at almost probably like 2.5. There are approximately 2.5 times 2.5, 2.5 times more males than females, which seems to imply that more men have heart disease than women. See, I kind of added my own little interpretation. Now, I don't know for sure that it's 2.5, but it's close. Let's see. 206 divided by 97. It's about 2.1. So I'm a little high, but I said approximately. So again, I'm stating facts, but I'm also kind of inserting my opinion as the researcher, and I'm using complete sentences. Okay. Now, in terms of the actual instructions for the mini project, okay, that's part 2. I just demonstrated it for you. But I also give you some examples that I pulled from the internet. Okay, I give you an example of interpreting a bar graph. Okay, so that you not only have the demonstration that I just did, but you also have a visual one on the mini project. The third part of the mini project gets into quantitative data, so we're going to get into that next. So do you have questions about qualitative data? Guys, I'm trying to let you know the expectations related to those mini projects ahead of time so that you'll know what I'm looking for. There are rubrics already available, so you can see what I'm going to be looking for when I grade it. Okay, so let's move on to quantitative data. Remember, quantitative data is numbers. So one of the type graphs that we deal with quantitative data is called a histogram. There's a star beside it because that is one of the graphs that you have to be able to create and interpret in Minitab and on Mini Project 1. Okay, a histogram is similar to a bar graph. It displays the data from a frequency distribution. Now, frequency distribution is a fancy statistical term to mean from a table, but I can also create it from the raw data, from just the list of data without having it in table form. The horizontal scale is labeled using either what's called the class boundaries or the class midpoints. And I'll explain that a little bit more in detail in just a minute. The vertical scale is your frequency. The biggest difference between the bar graph that we just looked at and a histogram is that the bars are contiguous. Okay, the bars are contiguous. There's no gap between the bars. They're smacked against one another. Okay, let me talk a minute about class boundaries and class midpoints. It comes from the frequency distribution. Typically, whatever technology you're using to create the graph will use whatever it's programmed to use. If I'm not mistaken, and we'll create one in a minute and I'll know for sure. If I'm not mistaken, Minitab by default uses the class midpoints. Let me see if I can kind of show you what I mean, and I may have to go back out here where I can mark on this. Notice in this graph on the upper right-hand side here, you have a histogram of quality defects. And so the horizontal here is the defects per hour. So you have in this block, kind of under the center of that bar is the number 2. And then it looks like it skips a bar and you have this one. So I'd be willing to bet if I put numbers in here, in the middle of this one would be 3. Then I'd have the middle of this one is 5. You know, they're counting by 2s just to kind of keep it from being so jumbled. Okay. So you have 2, 3, but notice how, again, the thing that's important to notice here is that it's kind of in the center of the bar. Okay, so this one really maybe goes from like 1.5 to 2.5. I don't necessarily know how you have a half of a defect, but I suppose you could. And then you have it goes from 2.5 to 3.5, from 3.5 to 4.5. So it's in the middle of the bar. So that's the class midpoint. On the graph on the lower, on the right hand side, the lower one, and they're hard to see, but you have a number at the beginning of the bar and a number at the end of the bar. It looks like it's 30.5 and then 40.5 and then 50.5, 60.5, 70.5. So they're using the class, that one uses the class boundaries. Okay, it uses the class boundaries, and it's showing you kind of the beginning point and the ending point. So really that group probably runs between, let's see, probably, let's see, if it's 30.5, we'd have to go 31 to 40. Okay, because you got that half unit, that lets me know that they're sharing it between the two groups. Okay, so again, you just need to know how to interpret it, okay? Because by default, Minitab is going to use whatever scale it wants. And again, I believe, and I'll double check for you when we create one in a minute, I believe Minitab uses the class midpoints, okay? Minitab is going to use the class midpoints. We'll come back and talk about it a little bit more at a histogram in a minute because we're going to learn how to create one. Some other graphs that you can have with quantitative data. You can have line graphs. If you're looking at produce sales, and they're in thousands of US dollars, and they have the months, October of 2019 through June of 2020. And again, the nice thing about the line graph is it very easily lets you see a trend of whether something's increasing or decreasing. You see line graphs a lot used, especially in relationship probably to sales, the stock market, that kind of thing again. But your horizontal axis is usually, in this case, it's actually dates or months. We could be looking at years, but it's you know, your labels, your categories, your groups. And then the vertical axis again is the frequency. We basically play dot to dot. Instead of drawing vertical bars, we draw dots. So a line graph is usually a kind of a combination because you have qualitative and quantitative data. But again, it allows you to see trends. If we're looking at the one on the lower left, or excuse me, lower right, I can see that the sales for desktops have decreased while the sales of tablets has increased. And then laptops have kind of been an up and down trend. Okay, so you can begin to see patterns and things there. Again, the line graph is one that's kind of a combination of qualitative and quantitative. Finally, the third one, and this one you are going to have to create as well, is a box plot. A box plot is definitely used with quantitative data. And it actually gives us a picture of what's called the 5-number summary and the outliers of a data set. And it always has 25% of the data between the minimum and quartile 1. I think I want to go out and draw this for you. It's a topic that we talk about in Stat 1401 in the first course. But if it's been a while you may not be familiar with some of these terms, and we haven't gotten completely into descriptive statistics yet, but I want to go ahead and try to draw this for you so you can kind of see what's taking place. Okay, so if we took our data set and we kind of ordered it from smallest to largest, then on our box plot, we think about a number line and we start out with a value for the minimum. We might be, maybe choose a value exactly equal to the minimum, or it could be, we could pick a value that makes sense. And then we run the number line up to at least the maximum value. And then on that number line, we're going to indicate basically what's going to happen is we're going to divide this number line from the minimum to the maximum into 4 different regions. Okay, so that we have a value that indicates the first 25%. If I'm doing 4, 100 divided by 4 is 25. So each section is 25%. Okay, so we take from the minimum to the maximum, and we're going to divide it into 4 sections where each section contains 25%. Okay, so this first tick mark represents what we call quartile 1. Or if you think about it as a percentile, it is percentile 25. Because that's the 20 at that point we have covered between the minimum and quartile 1 is 25% of the data. 1/4. Quarter is 25. If we move to the next tick mark, I've gone from the minimum to 25%, and I've gone another 25%. So now I have 2/4 or quartile 2, which would be percentile 50, or it has a special name called the median. Okay, if we go from the minimum to quartile 1, then to quartile 2, and then we go to the third tick mark, now we've gone a third 25% or a third quarter. So now I have 3/4. So this is quartile 3 or percentile 75. And so when we interpret these things, when you start trying to explain, well, what does that mean? Between the minimum and quartile 1, there is 25% of all the data values. And that's what I say on this slide, okay? 25% of the data values are between the minimum and quartile 1. Okay, between quartile 1 and the median, there is a second 25%. So really when I'm at quartile 2, okay, if I'm at quartile 2, because I have 25 and 25, 25 and 25 make 50. So I actually have at quartile 2, I have 50% of all the data values are below. I left that phrase out. That value. Okay, let me go back and put that in. Okay, 25% of all the data values are below quartile 1. 50% are below quartile 2. If I make it up to quartile 3, at quartile 3, I have 25, 25, and 25, which is 75. So I would have 75% of all data values are below Q3. Okay. Again, if you're kind of one of those people that maybe think about it in terms of a split, quartile 1 is your 25-75. You have 25% below it and 75% above. Quartile 2 is your 50-50. Quartile 3 is your 75-25. And the last quarter is between the quartile 3 and the maximum. Now, Minitab is going to calculate those values for you. We don't calculate them by hand. Okay, so Minitab is going to calculate them for you. But that's what the box plot displays. It's going to show me the minimum, quartile 1, quartile 2, quartile 3, and the maximum. If I draw a box, see, if I draw a box between quartile 1 through quartile 2 to quartile 3, that's where the box is located on a box plot. The box plot, on a box plot, the box goes from quartile 1 through quartile 2 to quartile 3. You have to have the box to make it a box plot. Okay, so here's some examples, and you can draw the box plot vertically or you can draw it horizontally. Minitab does it vertically. Minitab will also, a box plot will show an outlier. This particular display shows the outlier using this little dot. Minitab uses a star or the asterisk symbol. So this value out here, this little open dot, is an outlier. It doesn't seem to fit with the rest of the data. Okay, so I want to go out, and first of all, I want to show you how to do a histogram. And then we're going to talk about descriptive statistics, because that gets us back into the box plot. Okay, so I want to show you first how to do a histogram. Histogram is quantitative data. So again, from the data set that you're given, you can choose any variable that is quantitative. That's a number. So I could do age, I could do resting blood pressure, I could do cholesterol, I could do maximum heart rate. Okay, I could choose any variable to create my histogram. Okay, again, I already have the data entered. I've pulled the data set in. Minitab is kind of common sense. I want to create a graph. The graph I want to create is a histogram. So again, I go to the top menu bar to the word graph because I want to create a graph. And then I'm going to select the graph that I want, which is a histogram. I want to keep it simple. Okay. You can get fancy with it. All I ask you to do is keep it as simple as possible. We're doing one variable and we're keeping it simple. So I click on that option. I have to identify the variable that I want it to do. I'm going to do age. Again, I select it by double clicking. So I want to choose age. I move over to age, double click. Again, I can look at my options here. I don't really do anything extra. I just leave it. And I click OK. And again, what happens is my graph appears at the top. Okay, my graph appears at the top. Again, it says histogram of age. Not very descriptive. It's also the default, and Miss Ralston can tell it's the default. So we want to change it. So we click on the triangle in the upper right corner and choose options. And I might put ages, and I may say years of heart disease patients. Okay. My x-axis is age. Again, ideally you want to include the unit, so I would maybe indicate that it's years. And then I have the frequency, which is okay for the vertical. Then I close that window, and it makes those changes. Again, I can put my mouse over a bar. Okay, let's notice something here. Okay, this says the bar. It has a value of 1, so I had one person, and that particular bin or that particular group is between 29 and 31. If I move over here to the last bar, again, it has a value of 1, and it's between 77 and 79. Now, I can use that information because if this smallest bar is in the bin 29 to 31, it appears that, my ages for these patients are between 29 and 79. Now, I don't know if that one person is 77, 78, or 79, but I can say, if all I have is this graph, I can tell that the ages are roughly between 29 and 79. I can see that most of the people were aged 57 to 59. And let's see if I can tell. Let me go down here and look. Okay, it does appear that Minitab is using the midpoint, because see how this number 40 is kind of in the middle of that bar. Again, as long as I'm in Minitab, I can scroll over the bars and get information. Again, if I copy it to my Word document or to Excel or PowerPoint, then I lose some of that interactivity. But again, you have to create it, and then you have to summarize what it tells you. And again, on the instructions, Miss Ralston clearly says, use complete detailed sentences. Please follow the instructions. You are educated individuals, and you should be able to write a complete sentence. And again, I give you some thoughts or some ideas about what to think about. Okay, I also give you, we're fixing to do it as a demonstration, but I also give you an example. Okay, so if I'm looking at this histogram, I can say the histogram represents the ages in years of patients in the hospital who have heart disease. The patients ranged in ages from 29 to 79. Again, I was able to get that from Minitab with the interactivity. The lowest bar had a low value of 29. The highest bar had a high value of 79. I could say, you know, again, we could say the majority of patients were aged, you know, you can look at this tall bar here. Again, we have to go back to Minitab and get it, between 57 and 59. One of the things that I ask you to tell me, and I don't think this is on the PowerPoint, so you may want to make a note about it, is how is this particular distribution skewed? I think that's one of the questions that I ask you. Okay. Let's see. Do there appear to be any extreme values? What is the shape? Okay, the shape of the distribution is kind of the skewness. So again, it's not on this PowerPoint. It's something that is a carryover from Stat 1401, but you may have forgotten it. So I'm going to review those real quickly with you. Okay, there are basically 3 different distributions that we focus on. Okay, so you have the option that your distribution is skewed to the right. Skewed to the right, you would have your horizontal axis, again, usually running low to high. You would have your frequency on the vertical, and you would have lots of data at the beginning, but as you move out to the higher values, it tapers off. So that visually, if you're looking at it like a curve or a mountain, you have this hump on the low end, and then it tapers off as you move to the right. Okay, so skewed to the right, you have lots of data on the low end and very few on the high end. Now I'm putting this in everyday terms. When I think about this, I think about it as being backwards, because notice that this hump, the hump, is actually on the left side, but it's called skewed to the right. So I remember in my brain, I always think, okay, it's backwards. If it's humped on the left, it's skewed to the right. Humped on the left, it's skewed to the right. It's backwards to what you would think. Second option is that your graph is symmetric. Again, visually, if you're looking at it, your horizontal axis would go low to high. You'd have your frequency on the vertical, and it would look kind of like it's the same on both the left and the right. Okay, it doesn't have to be exact, but again, visually, if you're looking at it, your graph, you have very few on the low. Most everything is kind of clumped together in the middle. Okay, so for symmetric, most of the data is in the middle. You have very few low, and you have very few high. Third is skewed to the left. Skewed to the left, again, you still go low to high on your horizontal. You have the frequency on the vertical, but in this case, you have very few on the low end. And as you get out further, you have more and more on the high end. Okay, so that visually, when you're looking at the curve, your hump is on the right hand side. Okay, so for skewed to the left, you have very few values on the low end, lots of values on the high end. Again, I think that it's backwards because my hump is on the right hand side, but it's called skewed to the left. So if I go back to this histogram, guys, you don't want to get tunnel visions. You want to look at the big picture. So I'm kind of thinking, okay, you know, I'm looking at that one. I probably, if you were answering that question, I would probably accept that it was symmetric, because it kind of looks like most of them are kind of in the center. Or I might be willing to accept skewed to the left. Maybe there's a few more on that high end than on the low end. So if you're just using your eyeballs, it could be open to the interpretation of the researcher. Okay, and what I see and what you see might be two different things. Okay, now I'm going to show you a way a little bit later how we can confirm that. Second thing I'll say is you only talk about a graph, you only talk about a histogram or a box plot. Only the graphs that deal with quantitative data do we talk about being skewed left, skewed right, or symmetric. You would never say that with respect to a bar graph. Let me pull up a couple of other quick examples because I've got some histograms over here, I think. See, if I were looking at this one, it's a histogram. Again, thinking about it, I probably, with this one, would think symmetric. Kind of go with what, you know, think about what you, when you first look at it, what does your gut think? This one with defects per hour, I probably would go with more so with skewed to the right. Now, again, that's my gut instinct. You know, when I first look at it, that's what's jumping out at me. I could be totally wrong when I look at the numbers. Okay, we're going to come back to how to create a box plot a little bit later. So do you have questions about the histogram or how to think about the distribution? And that information on the distribution is not on the PowerPoint. All right, I got 26 minutes and we got to try to get through descriptive statistics. Okay, when you start thinking about specifically quantitative data, so we're focused on numbers, there are 5 characteristics that you want to be able to kind of describe in relationship to that data set. They are the center, variation, distribution, outliers, and time. The center is that representative or your average value that indicates the middle of the data set. So the center, when we think about center, we're thinking about the middle or the average. Variation has to do with how much the data varies between each other, but also from data set to data set. Excuse me. The distribution is what we just talked about, the shape. Do you have a lot on the low end and few on the high end? Are they all clumped together in the center? Okay. And so I've given you the three basic distributions that we're going to talk about: skewed to the right, symmetric, and skewed to the left. Those are the three you have to know. Outliers are just that. They're values that do not seem to fit with the rest of the data values. Okay. They are either numbers that are just way, way low, or they're way, way high. They just don't seem to fit with the rest of the data. And then time, I hope it's obvious that a lot of data can change over time. And so it's important that you know that. Now, that's the one characteristic we don't deal with a lot in either Stat 1401 or in this course, because we only have 15 weeks to discuss it. So we can't really look at time. But again, think about the price of eggs and how they've changed even from week to week in recent days. Okay, so there are three measures of center that you need to be familiar with. Minitab is going to do all of these calculations. Minitab is going to do all of the calculations for you. We do no hand calculations in this course. The measures of center are the M&Ms. You have the mean, which is what most people refer to as the average. It is the most important of the three measures of center because it is the only one that uses all of the data values in its calculation. Okay, and it's also used in other statistical formulas or other statistical calculations. So the mean is what most people are referring to when they refer to the average. The process is you would add up all the values and divide by how many you have. But again, we're going to let Minitab do the work. The mean is unique to that data set, but it also is influenced by outliers. If you have a lot of data values that don't seem to fit, it can cause your average to be inflated or deflated, to be higher or lower than it really is. And so you have to be careful about that. The median is the value in the middle when the data is ranked from low to high. I showed you quartile 2 a while ago that divided the data set 50-50. That's the median. Okay, the median is the one that divides the data 50-50. You have half the data set below, half the data set above that particular number. It may not be one of your data values. It could be, but it doesn't necessarily have to be. The median, because you're not actually calculating with it, is not affected as much by outliers. So sometimes if your data set has outliers, it may be best to use the median as your measure of center. Then you have the mode. The mode is the data value that occurs the most within the data set. The mode is also the only measure that is used with qualitative data. All these other measures that we're talking about apply to quantitative data. The mode can also be applied to qualitative, and it is the only one. But it's the one that occurs the most. Again, it's not necessarily unique because in some cases you could have a tie. Again, real quick, if I go back over here to my graph, I have 1 for 29 to 31. I had 1 for 73 to 75, 1 for 75 to 77, and 1 for 77 to 79. So in a sense, I have 4 values that had a frequency of 1. So I have multiple modes in that particular case. It's okay if I have multiple modes. It's also possible that you don't have a data value that occurs more often than the others, which means you have no mode. There's not one. The measures of variation, and I'm going through these quickly because this hopefully is a review from Stat 1401. Again, if it's been a while, if you want to reach out, I can give you a more detailed, slower video to watch. Measures of variation, again, there are 3 of those. They're range, standard deviation, and variance. The range is very easy to calculate. It is the maximum minus the minimum. The downside to that is if you're dealing with the range and you have those outliers, again, it's affected by those outliers. So it's a quick way to get an idea about the spread or the variation of the data, but it's not the best. The variance is actually, of the options, is really the best, but it is difficult to interpret. It's a much more useful measurement. It does take into consideration all of the data values, but again, it is difficult to interpret. It is called an unbiased estimator. What that means is that basically if I could calculate the variance for each data set or for the population, each data set, that it is going to basically hit the bullseye of the target. It's going to target the value for the population and be pretty much dead on each time. What I learned about the sample in relationship to the variance is pretty much right on target for the population. That's why it's called an unbiased estimator. But again, it's difficult to interpret because the units wind up being squared. So we would have to talk about, ages squared, years squared for ages. Or if we were talking about money, we would have to talk about square dollars. And quite honestly, that just doesn't make sense to us. So it's difficult to interpret. Instead, more times than not, we're going to use the variance. The variance is simply the square root of, the standard deviation is the square root of the variance. So if I'm looking for the standard deviation, okay, let's see, it's not going to let me right there. The standard deviation is the square root of the variance, or vice versa. The variance is the square of the standard deviation. Okay, they're connected to one another. But again, by taking the square root, my units go back to being years or dollars and makes the interpretation easier. Again, it uses all of the data values. So the standard deviation is the other most important measure for a data set. All the measures are important, but the 2 that are super duper duper important are the mean and the standard deviation, because they involve all of the data values and we use them in other statistical calculations. Now, the way we think about standard deviation, the larger the value for the standard deviation, the more spread out the data is. the more it differs from each other. Okay. Then we have, oh, and by the way, standard deviation is never a negative value, because if you take the square root of a negative value, it's imaginary. Can't deal with imaginary numbers in statistics. Then we have measures of position. We have percentiles. You see percentiles used a lot in education and in health-related fields. And it basically looks at a comparison of how a particular individual compares to the entire group. Okay, how an individual compares to the entire group. Percentiles divide the group or the data into 100 groups. A while ago, when I was doing the box plot, we talked about dividing it into 4 groups. Those are called quartiles. But if I divide it into 100 groups, I have percentiles. Again, that allows us to make comparisons about how a particular individual compares to a particular standard or the national norm. You'll see that a lot with like ACT scores, SAT scores, any kind of standardized test score. It's important that you understand how to interpret a percentile or quartile. And guys, the key thing about interpreting these is that it is the percentage that fall below that specific value. Okay, it's always the percentage below. There's lots of different ways to calculate percentiles. Different researchers do it differently. Different textbooks do it differently. So calculating a particular percentile is going to vary from researcher to researcher, probably even from software to software. And so we don't really deal with percentiles a lot in this course. And if we do, we're going to let Minitab do the work. A subcategory of that is quartiles. And the quartiles divide the data into 4 different regions, as I pointed out earlier. And again, we use those ultimately to help us determine if there are outliers. Okay, the quartiles can be used to help us determine if there are outliers. And again, when you interpret it, it is the percentage that fall below that rank. And I talked about that a little bit earlier, and I also have it delineated here on this slide. You also have what's called the interquartile range. The interquartile range is the middle 50% of the data. And that's between quartile 3 and quartile 1. Again, Minitab is going to calculate it for you. So there's lots of ways to display the data or display descriptive statistics. You can do it in tables. We can do it with graphs and so forth. So you're going to use kind of, I have you use what's called the 5-number summary. The 5-number summary has these 5 values. Okay, the 5 values are the minimum, quartile 1, the median, quartile 3, and the maximum. And then oftentimes you're asked to include a couple of other things. You want to include the mean and the standard deviation, again, because those are the most important, and then your sample size. Because we need the mean and the standard deviation and the sample size to calculate other things. So along with the 5-number summary, you'll give the mean, the standard deviation, and the sample. Now, how you display them, whether you write it in sentence form, whether you create a table, that is totally up to you. But Minitab is going to do the work. Then I give you some examples of how you can display them and examples of graphs. Okay. I got 10 minutes. Let me see if I can show you how to do this in Minitab. You have the data. Okay. You have the list. Even when you're looking at your homeworks, you have the list of the things you need to calculate. Okay. In this case, we need the 5-number summary, the mean, the standard deviation. I can calculate pretty much anything I want. Here's what we do. I've got my data set. Okay. Now I want to calculate the statistics. So I'm going to stat, basic statistics, display my descriptive statistics. I want you to get me those numbers. Give me those numbers. So stat, basic statistics, display descriptive. I have to tell it what variable I want it to calculate. Again, I'm going to use age. And then I'm going to use this little widget, this button that says statistics, to select all of the things that I want it to calculate. Okay. Now I'm going to mark them. Okay. So you want the mean, the standard deviation, the variance, first quartile, median, third quartile, interquartile range, the mode, the minimum, the maximum, the range. And then there's 3 options for N. N non-missing, N missing, and N total. And those are the things you will calculate every single time. I click OK. I click OK again. And Minitab gives me all of those numbers. I had a total of 308 in my sample. The N star represents how many were missing. In this particular variable, I don't have any that are missing. It gives me the mean, the standard deviation, the variance, the minimum, quartile 1, median, quartile 3, maximum, the range, my IQR, the interquartile range. It tells me that the mode was 58 and that it occurred 19 times. This last value out here that says N for mode is the number of times that the mode occurred. I can copy and paste these. Okay, I can copy and paste them into a Word document, into PowerPoint, whatever. Now it gets a little jumbled when you paste it because it's not formatted the same way, but everything is there. Real quickly, I want to go back to, we use these numbers. We look at the relationship between the mean, the median, and the mode to verify whether the distribution is skewed to the left, skewed to the right, or symmetric. There is a particular relationship that exists. So I want to give you those relationships real quick so that you can maybe go ahead and start working on your mini project 1. I don't think we're going to get through everything, but you can at least begin working on it. Okay, so skewed to the right, if we look at the relationship between the mean, the median, and the mode. For skewed to the right, the mode is less than the median which is less than the mean. So your values would line up. The mode is first, then the median, then the mean. For symmetric, the mean, the median, and the mode are all approximately the same value. Skewed to the left, you have the mean is the smallest value, then the median, and then the mode. So visually, I told you I would either take symmetric or skewed to the left. So let's look at the numbers. My mode is 54.439. Okay, so the mean, is 54.439. That's the mean. The median is 56, and the mode is 58. If I look at the numbers, mean, median, mode, the distribution of the ages is actually skewed to the right, to the left, skewed to the left. Remember, I told you I would take symmetric or skewed to the left. Visually, it looks symmetric. By the numbers, it's skewed to the left because the mean is less or smaller than the median, which is less or smaller than the mode. So you don't rely just on your eyeballs to determine the distribution. You can look at the numbers. It's kind of like you got to show me the numbers. You know how you let's see, what is it? Color of Money. Tom Cruise says, "Show me the money." You got to show me the numbers, and you can prove whether or not it is skewed left, skewed right, or symmetric. All right, I have run out of time. I have not had the opportunity to show you how to create a box plot. I did show you because one of the questions somebody had earlier in the week, and I told them we would address it tonight, is identifying missing variables. Okay, notice Minitab does that for me. For age, it showed I had no missing variables. But if I do it for a different variable, let's say I have it calculate those descriptive statistics for, let's do resting ECG. Okay. Again, it shows I have none missing. Okay. Maybe if I have, let's see, I thought I had one. Maximum heart rate. Maximum heart rate, we had a total of 303, but in star, which is the number missing, there were 6 that I didn't have a report on. So I have 6 missing values. So Minitab will identify the missing ones for you. In terms of identifying outliers, you look at the box plot. Now, guys, it's not hard to create a box plot. I got 1 minute. Graph, box plot, keep it simple, pick the variable, and it does it. In this particular case, notice that there's no stars. Okay. It tells me Q1, the median Q3, and there's no stars. So I don't have any outliers. Let me see if I can find one real quick. Graph, box plot, keep it simple. Let's try resting blood pressure. Okay. Notice on this graph, I have a bunch of stars up here. Okay. It says outlier symbol. the pressure was 172, 174. So all these stars on the box plot represent outliers. That's how you visually determine if you have outliers. There is a formula, but I don't have time to show it to you tonight, so I'll have to wait until next Thursday. Couple of things that I would tell you you need to do. One is quiz 2. I think you can get through quiz 2. Please start looking at mini project 1. You could at least get through identifying the data set, identifying the variable that you're going to do for qualitative and the one for quantitative. Then you should be able to do your bar graph. You should be able to do the histogram with the explanation. We didn't really get to box plot, and then we haven't gotten to the last few pieces here. Please, please, please do not wait until the last minute to start working on this. Please start looking ahead. At least look at your data set. Start thinking about what you're going to do. And most of all, follow the instructions. All right, I'm 1 minute over. I do apologize, but do you have questions before we go? I will have this recording posted by noon tomorrow. It takes a little while for it to process, so I will get it posted by noon tomorrow. And if you have questions, remember I have office hours on Sunday night. I have office hours in Zoom on Wednesday afternoons or at 5:30 prior to class starting. All right, you guys have a good weekend.
Thank you.